Hello, microeconomics students. This week's lesson is on chapter 24, which deals with monopoly. And I wanted to offer some help with the homework. Monopoly in some ways is going to be familiar, in some ways is going to be very unfamiliar. My advice would be to try as many different versions of these problems as you can, just to get comfortable with the format. So this first one shows you the graph of a monopolistic catfish farmer. And some of this might look familiar. For example, the average total cost curve faced by the monopolist is the same as it would be for another type of firm, a more competitive firm. Marginal cost curve, again, that upward sloping curve that we looked at in previous chapters. Marginal revenue curve is a little bit different because with the perfect competitor, that marginal revenue curve was perfectly elastic. In this case, the monopolist has a little more market power, and because of that does not have to take and charge only the market price. The monopolist can charge whatever price the market will bear, which is indicated by the demand curve. So we have some different looks of the graph here. Also, there's only the one graph because the firm is the entire market. That's the whole premise of monopoly, one mono. So from the graph given, there's some information that we can pull. It says, what is the highest price the monopolist could charge and still sell fish? We're just going to look at the demand curve for that first one. And we say, well, if they charge $13, they can sell 1 unit of fish, 1 bushel of fish per day. If they charge $14, they're not going to sell any. So the answer here is 13. Now remember, the numbers you have in front of you will probably be different, but if you're reading the graph the same way, you should see it. What is the total revenue at that highest price? Well, I'm going to sell 1 bushel at $13, so it's going to be 13 times 1, or $13 in revenue. What rate of output maximizes total revenue? Now, this is a little bit different. Total revenue is maximized where the marginal revenue is greater than 0. Because as you might have noticed in the chapter, marginal revenue means the additional revenue as each unit is being sold. As long as you're getting more additional revenue, it's still positive. It's still growing. At the moment that it becomes negative or less than 0, then it starts to eat into the total revenue. If you think of revenue as a pile of money, as long as you're adding to it, the pile grows. But the moment that you have negative or take away from that pile of money, then the pile starts to get smaller. So here, where do we maximize total revenue is at any point where total revenue is greater than 0. And so it's a little hard to see here, but if we kind of extend that line down there, we can see that total revenue maxes out at 7 bushels. If my line were better there. So it's still positive. At the point that it crosses over that line, it becomes negative and it starts to eat into those total revenues. Therefore, we maximize it where it's greater than 0. At what rate of output are we maximizing total profit? Now, this is going to be familiar because in previous chapters, we talked about that profit maximizing output rule being MR equal to MC. And that same rule still applies with the monopolist. So we can find MR equals MC is our profit maximizing output. Here's our marginal revenue curve. Here's our marginal cost curve. So profit maximizing output level is 4 units, or 4 bushels in this case. And what's marginal revenue at that rate of output? Well, we can see that pretty easily. It is $7. And the price at the profit maximizing rate of output. And then this you're going to carry up to the demand curve, and that's the price that the monopolist will charge. They will charge what the market will bear. So in this case, if 4 units are produced, the market is willing to buy only 4 units. And they're willing to pay $10 for those 4 units. So the price is at that demand curve. You find your maximizing point, marginal revenue, marginal cost. Then you carry it up to the demand curve. So that's the big difference with the monopolist. And it's something to get used to and practice again and again. Reading these graphs is a little bit tricky at first, so getting used to it is the key. Number 2 is going to ask you to do a lot of calculation with the information for the monopolist. Now, a lot of this looks the same. The formulas are the same. So total revenue is price times quantity. It's just a few things to just jot down here. Total revenue is price times quantity. Don't let that worry you. It just means how many we're selling at what price. Marginal revenue is the change in total revenue divided by the change in quantity. And in this case, the quantity only changes by 1 each time. So that's going to be nice and easy to work with. So total revenue here, 0 at $27 is going to be 0. 1 at 24. 2 at 21 is going to be 42. 3 at 18 is going to be 54. And 60 and 60 and 54 and let's see, 6 times 7 is 42 and 24. Okay, so the total revenue is pretty simple calculation. Marginal is simply the change in total. So from 0 to 1, we have a change in quantity of 1, so that's in the denominator. It's not going to be an issue. The change in total is 24, so it's going to be 24. From 24 to 42 is 18, and 42 to 54 is 12, 54 to 60 is 6, 60 to 60 is 0, and then we go into the negatives here. 60 to 54 is negative 6, 54 to 42 is negative 12, and negative 18. So it's important to recognize that marginal revenue can be negative. As we saw in the previous graph, it crosses below that 0 on the horizontal axis and it becomes negative. They ask you on part B, at what rate of output does marginal revenue turn negative? Well, we can see that right here. It turns negative at an output of 6. So what rate of output? 6. So this is just reading the information. If marginal cost is constant at 12, what's the profit maximizing rate of output? So we're going to go back to that rule. Marginal cost equal to marginal revenue is the profit maximizing rule. Well, they've told us that marginal cost is going to be 12 and it's constant. And so we're going to look for marginal revenue of 12. And you notice how we calculated it right here? So here it is. Marginal revenue of 12, in the numbers I'm working with, says the profit maximizing rate of output is 3, because they're asking for how many units are going to be produced. And then at what price is that going to be sold? And we can see the price those 3 units will go for is what the market will bear. That's the demand curve if we were graphing this. So the price is going to be at $18. So watch out, your numbers will be different, but working through these calculations, it isn't so scary as it's just helpful. It's practice. And you might write it out neatly, not like I have it, on a separate sheet of paper and see if you can't work through it again and again until you feel really confident in your ability to do this. Number 4 is going to be more of the graphical. And in this case, they give us demand information for a local utility service, and they want us to put in the demand and the marginal revenue curve on the graph. And you have a tool there that will help you do it. But let me just kind of show you, you've got your price and quantity demanded. This is going to be your demand curve. So you could plot these points in pretty easily. So at a price of 6, for example, quantity demanded is 20, and I'll do my best to put this on here correctly. At a price of 5, we've got quantity demanded of 50, and 4 is 90, about there, and let's see, 3 is 150, 2 is 210. 2, out there. So you're going to have your curve, and I'm imagining that they give you a straight line to work with, so I'm sure my graphing isn't perfect, but it's using the information given. Then you're going to graph your marginal revenue curve. This is where you don't have the information and you're going to be figuring this out. So what you'll do is you can take your price and your quantity, and you can set it up like this. I like to see it all in order. So this is what I would have done. Price and quantity demanded, and then total revenue, and then marginal revenue. So we've got our information, and I'm going to leave it in the order we see it here, just to keep it a little bit organized. And the quantities demanded were 20, 50, 90, 150, 210. And then the total revenues can just be price times quantity is total revenue. So 120, 250, 360, 450, and 420. Now the marginal revenue, watch out for this one. This one's a little trickier than the ones we have done in the past, because marginal revenue is the change, let me write the formula down here, is the change in total revenue divided by the change in quantity. And the change in quantity here isn't that nice neat 1 every time. So you're going to set this up and it's going to go like this. Your change in total revenue for that first one, well, you're not going to have one for that first one. For the second one, your change in total revenue is 130. However, it's going to be 130 divided by the change in quantity. So it goes from 20 to 50. So it's going to be 130 divided by 30. The next one's going to be your change, which is 110, right? 250 to 360 is 110, divided by 50 to 90, which is 40. So you're going to get some specific values here, and you're going to put that curve on the graph, and it's going to be less than. And in the reading and in the PowerPoint, there's a discussion of why marginal revenue is less than price or the demand curve for the monopolist. And basically the answer is because in order to sell additional units, the monopolist can't charge a different price for every unit that they sell. They sell them all at the same price. So if they want to sell additional units, they have to lower the price of all units. So marginal revenue will always be less than price on the demand curve for the monopolist. I think that was everything for that one. Okay. Number 6, more graphing. This one is going to look at the idea of maximum price and consumer surplus, but rather than that, we're going to look at costs and revenues and then profits from that. So here we go. We've got some information. This is what buyers are willing to pay for a Mini Cooper. And the cost of the producing cars is given to us here. It's $40,000 the fixed cost, and marginal cost, constant, meaning that they are always, $10,000 for each car that's made. So we're going to graph the demand curve and the marginal revenue curve. So we're going to want to get some information here. So we're going to go price, quantity demanded at that price, which is not the same as what we see here. We're going to look at total revenue that we would earn and marginal revenue, since we're going to be putting all that together. So let's start with the price of $50,000. And what we see from the chart is that one person will buy at $50,000. So total revenue is $50,000, and marginal, we don't have a change yet. All right. For the second one, well, let me go to the next price. At $40,000, now 2 people will buy because we have one more buyer, right? We have the one at 50, and now we have the second one. So 2 people will buy at $40,000. That brings in total revenue of $80,000. And now the marginal is the change in total divided by the change in quantity, which is 1. So our marginal revenue here is $30,000. We'll go to our next price, $30,000, and now 3 are demanded, bringing a total revenue of $90,000, marginal revenue of $10,000. And then we can go to $20,000 and $10,000. And we can say, well, 4 are purchased or demanded and 5. And we can just do the simple revenue calculation. And the marginal revenue is, now watch out for this one, because from 90 to 80 is a negative 10,000 in marginal revenue. And that's an 80 comma. 10,000 times 5 cars sold is 50,000. So the revenue is a negative 30,000, the marginal. Okay. So all this information is going to go into our graph. And there is one more piece of information to put in, and that's going to be at a price of 0, 6 are demanded, but there's 0 revenue. And the marginal will be a negative 50,000. I just didn't have a place to write all that. So then we're asked to pull out to go ahead and graph the demand curve, which is going to be right here. Here's our demand curve, and our marginal revenue curve, which is going to be right here. These two pieces of information. So if we put in our demand information, one is going to be purchased, and it's a little hard to see. Let's see if I can make that work. One is purchased at 50,000. Oh, let me put it in the right spot. 1. And then 2 are purchased at 40,000. And 3 at 30,000. Graphing should be pretty easy. And 4 at 20,000. And 5 at 10,000. And at 0, at a price of 0, 6. So we're going to assume that this is a pretty accurate demand curve. So we've got that. Connect the dots. I think you'll use the tool here for that. Then the marginal revenue curve, which is going to sit below the demand curve. And we're going to connect the the marginal revenue and the quantity. So I told you price and marginal revenue. I meant quantity and marginal revenue. So for that first one, that's not going to factor in. The second one, at a quantity of 2, the marginal revenue is 30,000. So we'll go here, and it'll go here. So it'll pick up at the same spot. At the third one, it's going to be 10,000. Marginal revenue is going to fall here. The fourth one is going to be a negative 10,000. So it's going to sit below. Let's see if I can make this graph look normal. And then the fifth one, negative 30,000. And the sixth one is that negative 50,000. So here's our marginal revenue. It sits below. It's a little strange looking. But we can pull out all that information from what's given to us. And the cost of producing them, 40,000 constant marginal cost. Now, I believe it asks about profits and some other details. Let me see if that showed up here. I think I forgot to put that in here, but let me just run you through this. Your homework is going to ask you for a few things. Your homework is going to ask you the profit maximizing price and quantity in this market. So profit maximizing, this is part B. And profit maximizing is going to be where MR equals MC. So marginal revenue is equal to marginal cost. And they've given you the marginal cost curve here at 10,000. They said it's constant. Right? So we've got marginal revenue equal to marginal cost. And so you've got your profit maximizing output is MR equal to MC. In this case, we can see it's at a rate of 3. The total profit earned, and this is where those cost calculations are going to come in handy. Well, at 3, at a unit output of 3, here's what we know. Our total costs are 40,000, that's the fixed cost, plus 10,000 for each of the 3 cars, because they're constant marginal cost of 10,000 each. So it's going to be plus an additional 30,000 because we're producing 3 cars. So our total costs are 70,000. Those 3 cars are going to sell for, we've seen this already, 30,000 each. So our total revenue for those 3 cars is going to be 90,000, right? We sell each one for 30,000. So total revenue of $90,000 minus total costs of $70,000 leaves profit of $20,000. So when they ask you about profits, you just need to remember the formula. Profit is total revenue minus total costs. So all that information is given, you just have to kind of find it and put it all together in a way that helps you see those things. Finally, they ask in this one, and again, I didn't include this in the picture, but you'll see it in your homework, about price discrimination. If this firm is a monopolist and they are able to price discriminate, and there are only very specific conditions under which a monopolist can price discriminate, but should they have those conditions met, what would they do, how much would they sell, and what would be their total profit? So here's how we can see that. It's actually right here in this information. If they could price discriminate, what that means is they'd sell to each buyer at the price they're willing to pay. So the buyer 1 would pay $50,000. They'd sell the car to them for $50,000. Buyer 2 would pay $40,000. Buyer 3, 4, 5, and so on. And so what would happen is they'd have total revenue, and of course they would not sell this one for $6,000, but they'd have total revenue of $150,000 if they price discriminated. I'm going to put that over here. And they would have total cost of, and we're going to go back to those cost figures, $40,000, that's the fixed cost, plus the $50,000 because $10,000 constant marginal for each car. So your total cost becomes $90,000. Total revenue, $150 minus total cost of $90 leaves you with a profit if we're price discriminating and selling those 5 cars at the price people are willing to pay. Leaves us with a profit of, I know you're way ahead of me, $60,000. So you're going to probably get different versions of that. I would strongly encourage you to just work through it. Try it. I understand the desire sometimes to just get through the homework, but since it's risk-free and it can't hurt you, try the other versions of this and see if you can't get more comfortable with it. Number 7, another graphing problem. So this one gives you the information about demand for soda on campus and the marginal cost of supplying a soda of 50 cents. And they ask you what price will students end up paying in 2 different market structures, perfectly competitive and monopolized. So here's what you can see. If you look at this, you can tell what total revenue and marginal cost are for these. My idea of this is I like to see it a little differently, so I'm going to set it up a little differently down here. So I'm going to have price, $2, $1.75, $1.50, $1.25, $1.75, 50 cents, and 25 cents. Okay, so that's the price column. The quantities demanded at these prices are 30, 40, 50, 60, 70, 80, 90, and 100. And then we can do the rest from here. So we've got total revenue, marginal revenue, and marginal cost, which is given to us as that 50 cents. So for marginal cost, we can already say, well, for each one, it's 50 cents. And then we can calculate the revenues. So here we've got just price times quantity equals total revenue. So we've got $60 and $70, $75, $75, $70, $60, $45, and $25. Okay, so we've got that information. Marginal revenue is going to be, now watch out, this is one of those tricky ones, it's going to be the change in total revenue divided by the change in quantity. And the change in quantity is always 10. So you're going to have some little bit different calculation than what you might be used to. So here we go. So for the marginal revenue for the first one, it's the change in total, which is 10, divided by the change in quantity, which is 10. So we're going to get 10 divided by 10, so $1 in marginal revenue. The next one, we're going to have a change of total revenue is 5 divided by a change in quantity, or quantity is 10. So we're going to get 50 cents. Okay. Then we're going to get the next one. Change is 0 divided by 10, which is going to be a little bit weird here, but so because of that little bit of mathematical weirdness, we're just going to put a no value there. From 75 to 70, we've got a negative 5 divided by the change of 10, and that's going to be a negative 0.50, so watch out for that. Then we're going to have a negative 10 from 70 to 60 divided by 10, so it's going to be negative $1. From 60 to 45 is a negative 15 divided by 10, so negative 1.5. And then we've got from 45 to 25 is a negative 20 divided by 10, so it's a negative $2. Okay, so that's all the information that we need here. Is now we're going to just pull out the information to answer the question. So what would students end up paying in a perfectly competitive market? Well, it's where MR equals MC, and if marginal revenue is 50 cents, it means that they're going to pay 50 cents. So they're going to pay 50 cents, and if we come here to 50 cents as the price, and sorry about that, I had $1.50 there, that should be a 50, right? I'm sure you saw that. 50 cents, that means 90 are going to be purchased, and they're going to pay 50 cents. And the reason I know this is because when marginal revenue is equal to marginal cost, that's where they're going to produce, right? So I was told marginal cost is 50 cents. Therefore, where marginal revenue is equal to marginal cost. So this one, marginal revenue equals marginal cost. So that's kind of a gimme. The monopolized market, however, is still going to produce to MR equals MC, but we're going to look for where marginal cost equals marginal revenue. So it's going to be here in this case, and they're going to be producing 50 units and selling them for $1.50. So watch out for that one, because remember, the competitive firm receives their marginal revenue is always the same from the market, and the monopolistic firm is going to produce at that profit maximizing output, but they're not going to charge that same price. They're going to charge what the market will bear. So in this case, it's $1.50. All right, so that one's a little setup involved, but can be done. Number 11 is our last one that I'm going to go through, and this is, again, just doing the calculations and getting comfortable with how all of these things work together to give us the information that we need. So we're going to complete the table, and we're going to summarize weekly sales and costs for a monopolist. And they're asking for whole numbers here, so kind of watch out for that. And so here we go. We're going to do total revenue first. This is really easy. Price times quantity equals total revenue. So 22 times 0, 20 times 1, 18 times 2, 16 times 3, 48, 14 times 4, 56, 12 times 5, 60, 60, and 56. Okay, so those calculations, really simple. Marginal revenue is going to be the change in total revenue divided by the change in quantity. Now, it's just 1 here, so that's going to be super easy. So it's going to be the change in total revenue. So from 0 to 20, from 20 to 36, from 36 to 48, so on and so forth. So that part, pretty easy. Then we're going to go over here to total cost. Now those values are given to us. Marginal cost is the change in total cost divided by the change in quantity. And like we saw previously, the change in quantity is 1. So this is going to be really easy. From 4 to 8 is 4. From 8 to 13 is 5. 13 to 19 is 6. And so on and so forth. So we're going to see the change in total cost, basically. And then average total cost is total cost divided by the quantity output. So all of these are easy calculations. Sometimes it's just remembering how to do each one on their own. So average total cost, well, you've got total cost divided by output, so 8 divided by 1. And then we've got 13 divided by 2, which is, sorry about that, 6.5. And then you've got 19 divided by 3, and you'll do some math with your calculator, but you shouldn't have too much trouble with that. So all of those calculations, pretty straightforward. The next part is to graph those things. So you're going to put your demand curve is going to be price and quantity. So you'll graph that here, and I'm going to kind of estimate this. So let's see, I've got 22 and 0. I've got 20 and 1. And I'm estimating here 18 and 2. About there. So on and so forth. So I'm going to have my demand curve slope down. I'm sketching it here. Then I'm asked to put my marginal revenue curve in. My marginal revenue curve, we know already, is going to sit below my demand curve, and you just graph your information between the marginal revenue and the quantity demanded. So I'll do the first few points. At 1, the marginal revenue is 20. It's going to start about here. At 2, marginal revenue is 16. And at 3, it's 12. So you're going to see your marginal revenue curve sit down below the demand curve. Then they ask us to put the marginal cost curve. So, well, we've got our marginal cost information and our quantity. So we're going to put that on the graph together. So I'll sketch the first few points. At 1, our marginal cost is 4, and I'm assuming that's where that point is. At 2, our marginal cost is 5. At 3, it is 6, and so on and so forth. And I know I'm way off on my graph, but you hopefully, oops, I don't know what just happened there. That was weird. Let me move that back where it was. Huh. And so here we go. We've got that marginal cost curve upward sloping. Now my graph is terrible, but yours will be very, very nice. And then we can answer the questions from here. At what rate of output are profits maximized? MR equals MC. So you're going to find those points. You can find them graphically, or you can come up here and find the numerical place where they come together. And I'll let you work through that. I think it'll be fine. What are the values of MR and MC at the profit maximizing rate of output? So that's going to be really easy. In my case, I think I hadn't worked out all the numbers here, but if we go 48 to 56, it's 8, and 19 to 27 is 8. So here it is. MR equals MC. The values of each are 8. And by the way, the number of units, MR equals MC, is 4. So you can see it numerically. All right. What price will the firm charge? We're going to go to where MR equals MC and then carry up to the demand curve. And we can see it numerically in our chart here. At an output of 4, the price that the monopolist will charge is what's on the demand curve. So $14. And total profits, well, we're going to find total revenue minus total cost at an output of 4 units. Well, 4 units at $14. So our revenues are going to be $14 times 4 units. And then our costs can be found up here at 4 units as well. Our total costs are $27. $27. And there's our profits. And then finally, if a competitive industry confronted the same demand and costs, how much output would it produce in the short run? And you're going to find where it's, and then this is an approximate one. This is between two values. But for this one, for perfect competitions, where supply equals demand. Well, you already have the demand curve. What you don't have is the supply curve. However, for the firm, supply is equal to the marginal cost curve. So you're going to find the point where marginal cost is approximately equal to demand. So you can use that numerically, or you can do it from your graph. But you should be able to see between two values where one is equal to the other approximately. All right, well, this is a challenging chapter. I would advise you to ask questions if you have them, and I would try the different versions of the problems. I would write them out. I would go through the numbers. If you struggle with something, try another version of it. It's challenging material, but once you get it, you'll be really comfortable with it, I think, over time. Good luck.